Hello, this is Dr. Hasan Abdullah with a video on creating the charts and then adding 10 lines to those charts using Microsoft Excel. So let's start with the video, and the sequence of this video and my presentation will be as follow: data generation and collection. So of course everything requires data for the purpose of charting. So I will not actually show you how the data is generated, but we'll be using the data which has been generated and the data which has been collected. So that is raw data, and that data needs to be compiled. So whatever is useful that is needs to be extracted or removed from the generated or collected data. So that's what I call as data compilation. So we'll work with a very small set of data so you understand the concept. So once data has been compiled, it is still not in a form that it can be used. So that data needs to be organized. Once data is organized, then we may be able to find and discover the patterns or the relationships we are looking for. So once we have that data organized, then or we can create the charts, and I'll show you that without organizing the data how the chart would look like and what information it carries. So once that has been done, then we will be adding the trend line and the equation to it. So let's move ahead, and we have here is the raw data generated. So I have dimmed it on purpose, but you can see that there's a lot of things which are not numeric in nature, and we need to process them, we need to remove them. And this is 7 runs of certain algorithms or computations. So now let's move on to Microsoft Excel. We discovered something at location 4, and this is the time with algorithm 1, and this is the time with algorithm 2. And then we discovered it again at location 4, the time remains the same, and discovered at location 0, so the time is 0 for both algorithms. Discover at location 3 and the time is 0.003 seconds, or and the time is different for the other algorithm. So we want to plot a chart which shows us. Now you'll have to be look at carefully. So if I select everything, okay, if I select everything, I go to insert and I go to this charting option and I select this. This chart is meaningless. Why it is meaningless? Because of the scale. We cannot see the times, okay, time 1 and time 2 cannot, because that is in kind of in milliseconds, and this location is an integer, so nothing is visible. See, this is just a loss. So that was a bad choice of selection. So I remove this and I only select these times. Right? And then I go to insert and I again go to the charts, and right now chart title could be, say for example, time comparison, time comparisons. Okay, time comparisons. Now this is fairly random. It doesn't show anything. Okay, it doesn't show anything. What it only shows that the scale of time 2 is larger as compared to the scale of time 1. That's only it shows. It's fairly random. The reason being that this x-axis over here it is in ascending order, but over here it is random, so we need to bring it in a certain order, in ascending order. Okay, so now I select all of this data and I go to custom sort. And custom sort, I select the option of sorting with reference to only the location and smallest to largest. Now if I sort it, now you see it's kind of magical. Now we can clearly see the relationships, and we can see that this is almost linear and this is non-linear. Now this is just by observations, it's not very scientific. So we want to do is properly. So I click on this, left click, okay, and then I right click on it, and it shows me add trend line. I go to add trend line. So there are many ways of linear, logarithmic, polynomial. So it is obvious it's polynomial, and the default is degree 2, otherwise it would be linear. And then I go to display equation on chart. So this is the equation, it is displayed, and we can see that it is fairly quadratic. Okay, it's quadratic. Now we also do this for this other line. I left click on it, then I right click on it. Okay, I go to add trend line and I select the linear option and display equation on chart. Okay, and this equation is displayed, and we see that this is linear. Okay, it's fairly linear. So this basically is the complexity function. Its order is order n square or x square, and this is linear, is order x or order n. So now we can see clearly that this algorithm 1 is linear in nature for searching, and the algorithm 2, which is orange in color, that is quadratic in searching. And we can fairly do a very formal analysis based upon this. And of course, this also shows that the complexity analysis actually reflects in the actual clock time. And this analysis will be very useful for your current work and your future work. So that's all I have for you. Thank you very much.